We saw how to parametrize the intersection of two curves. And we saw one method for doing that. Sorry, it's not intersection of two curves, but rather intersection of two surfaces. The intersection of two surfaces will give us a curve. And so the example that we did in class was the two surfaces were x squared minus y squared is equal to z minus 1, and x squared plus y squared is equal to 4. And so our method in class was we wrote everything. We wrote y in terms of x, we wrote z in terms of x, and then we replaced x with t to be our parameter. And so that's a more general method. However, in this case, there's a method that you might find to be a little bit more simple. And the reason we can get away with this is using the fact that x squared plus y squared is equal to 4 is one of our surfaces. That, of course, is the equation of a cylinder. And so we can parametrize we can parametrize the cylinder independently of z by saying that, well, independent of z, we just go to the xy plane. This ends up being a circle just in the xy plane. So we could parametrize it with x is 2 cosine t, y is 2 sine t, where t runs from 0 to 2 pi. So if we want to parametrize our cylinder, which looks like a circle in the xy plane, we can just use the standard parametrization for the circle. And so at this point, now we have x, and so instead of writing y in terms of x and z in terms of x and replacing x with t, in this case we have x in terms of t, y in terms of t, and so now we need z in terms of t, and we can do that just by plugging in x and y in terms of z. So what does that give us? Well, x squared is 2 cosine t, all of that squared. Y squared is 2 sine t, all of that squared, is equal to z minus 1. And so we end up with 4 cosine t, all of that squared, 4 cosine squared t, minus 4 sine squared t is equal to z minus 1. Let's move that plus 1 to the other side. So z is equal to 4 cosine squared t minus 4 sine squared t is equal to z. If you know your trig identities well, you can realize that cosine squared minus sine squared is cosine 2t. So if you wanted to rewrite, you don't have to, but if you want to rewrite this a little bit more simply, that's just going to be 4 cosine of 2t plus 1. So in either event, whether you want to stop here or go on to this, we have x in terms of t, y in terms of t, and z in terms of t. And so we can have our parameterization for the intersection of these two surfaces that forms a curve as x is 2 cosine t, y is 2 sine t, and z is 4 cosine 2t plus 1. And once again, our bounds were t runs between 0 and 2 pi. So this is an alternative method for parameterizing the intersection of two surfaces. I think it feels maybe a little bit shorter than the other method, which is nice. However, it relied on the special fact that we had this parameterization for the cylinder here. So it has its pluses as its downsides. I just wanted to show this to you so you have another tool in your toolkit.